We will now introduce TAIYO YUDEN smell sensors. We would like to share some details on the development status of smell sensors. First, we will provide an explanation of the function and mechanism of smell sensors. Smell sensors have been developed using the human sense of smell as a reference. Smell molecules are detected when they are adsorbed into the sensor's sensitive membrane. Therefore, the development of membranes that can adsorb various smell molecules is key. A detected smell molecule is converted into an electrical signal and quantified by the transducer. A QCM-type smell sensor quantifies a frequency change, while a MEMS-type smell sensor quantifies a resistance change. By using machine learning, smells are identified from the quantified data. The sensor identifies smells using a configuration similar to that of human smell sensing. If the sensor becomes capable of identifying smells, it would become possible to visualize smells and address various social issues. This includes the detection of hazardous smells both inside and outside factories, as well as the detection of hazardous materials. Let's examine the details further. The horizontal axis represents the classification of smells and changes in their quality, while the vertical axis indicates accurate evaluation and real-time detection. Sensory evaluation requiring smell identification by individuals and quality control for products based on smells place a heavy burden on human employees. We also believe that it would be a substantial benefit if the detection of hazardous smells that humans must avoid, as well as various other odors, could be visualized by the sensor in real time. TAIYO YUDEN promotes development with the idea that QCM-type smell sensors will be suitable for sensory evaluation and quality control, while MEMS-type smell sensors will be suitable for danger detection and anomaly detection. As indicated, we are also developing highly sensitive transducers. Next, we would like to explain the detection principles of the two types of smell sensors. First, let's look at the detection principle of the QCM-type smell sensor. In the QCM type, electrodes are mounted on a crystal substrate, and voltage is applied to achieve vibration at a specific frequency. A sensitive membrane is formed on these electrodes to adsorb smell molecules. When smell molecules are adsorbed, the frequency changes by delta F, proportional to the weight change delta M. Smell sensing is performed based on this frequency change. To detect smell, multiple sensitive membranes are prepared for sensing. The QCM type uses 16 types of sensitive membranes to detect smells through 16 channels. Molecules of different smells adhere to the sensitive membranes differently across the 16 channels. This diagram shows that the same sensor responds differently to type A smell and type B smell. This difference in response is learned by machine learning to identify smells. Next, we would like to explain the detection principle of the MEMS semiconductor-type smell sensor. In the semiconductor-type sensor, smell molecules adhere to the sensor surface and undergo a redox reaction, changing the resistance value and thereby sensing the smell. We have achieved higher sensitivity compared to commercial products from competitors. Smell identification after sensing is performed by machine learning, just as with the QCM sensor. Next, we will introduce the reproduction of smell. We are conducting joint research with the Institute of Science Tokyo on olfactory displays. By applying our SAW device technology, fragrances can be atomized. By changing the mixing ratio of small amounts of fragrances, a wider range of scents can be reproduced. By reproducing scents, New olfactory experiences would become possible, such as immersive gaming, shopping, and cooking. TAIYO YUDEN will continue to develop technologies focused on the theme of smell. This concludes the presentation of TAIYO Yuden's smell sensors. Thank you very much for listening.